To prove this identity, let's start with the left-hand side. So what we are going to be working on is trying to show that sine theta over 1 minus cosine theta minus 1 over sine theta can be re-expressed as cotangent theta. I am going to try to work on the same denominator to combine this into one single expression, and that common denominator will be sine theta 1 minus cosine theta. So this will be sine square theta if I were to multiply the numerator and the denominator by sine theta, and the denominator will be sine theta cosine theta. And this, I'm going to multiply the numerator and the denominator by 1 minus cosine theta. So the denominator will be sine theta and 1 minus cosine theta. Combining this now into one single expression, it is going to be sine square theta minus 1 minus cosine theta divided by sine theta 1 minus cosine theta. Sine square theta we can re-express into 1 minus cosine square theta. So 1 minus cosine theta, this is going to be here. The denominator will be sine theta 1 minus cosine theta. Let's factorize this by treating 1 as if it is 1 square. So we can re-express this as 1 minus cosine theta and a 1 plus cosine theta. Because now we have a case of a square minus b square, which is a minus b, a plus b. Then minus 1 minus cosine theta, this divided by sine theta, there's a close bracket here, 1 minus cosine theta. We can now factorize out 1 minus cosine theta, since this is the common expression for this term and this term, which will then leave us with a 1 plus cosine theta minus 1. So this divided by sine theta 1 minus cosine theta. And 1 minus cosine theta in the numerator and the denominator can be cancelled. And in the numerator now we are going to be left with 1 minus 1 cosine theta divided by sine theta. And this is cotangent theta, which is the right hand side.